Hi, substitute. How are you doing? And hi, class. Here's what we're going to do today. First, on my desktop is an introduction to the microscope lesson plan in MP3, a microscope lesson plan in a Word document with links that work, and a virtual lab icon. So what I want you to do first is to open the virtual lab, put it on the smartboard, have that open. You can download any of these items that you see for fun. They will get added to this banner on the top. Let's take a look at one. There's a moss sporophyte. That's the end of the moss, the tip of the moss. And we have different levels of magnification that we can look at. We can play with the contrast to look at different items and so forth. We can even save it on our laptop. And we can close this. Oh, that's close. And we can unload and go back and look at something else. So download some of these things that are biologically based and practice looking through the microscope virtually so that you can see what you're going to be looking for when you look through a real microscope. It's a little bit harder, but at least you'll have a better idea of what you're supposed to focus on and be able to focus so that you can see using the actual microscope. So one of the first things we want to do is we have a list of vocabulary and a handout for you. And we have photographs that are labeled of the different microscopes you'll be using. All microscopes have a light source that might be simply an overhead light or a more intense light from the side that's from overhead, or it might be a light in the base that shines light through a specimen that's on the platform we call a stage. This is the base of the microscope. Let's go to the top. The lens you look through is the ocular lens. It's closest to your eye. There may or may not be an adjustment up here in the fancier, more expensive dissecting microscopes. There will be, so that you can adjust this binocular head to match your prescription of your glasses. In some cases, we'll only have one viewing tube, but it's nice when you have a stereoscope and have one for each eye. There are two magnification adjustments, or two adjustments here. One is, in this case, the power of the magnification. Sometimes there'll be different lenses here that you'll flip among. Most of the time, you simply have a zoom lens in a dissecting microscope. Then you have a focus knob, which actually raises and lowers the apparatus in its attachment on the microscope arm. So you'll take a petri dish, put a sample on the stage, and adjust your focus by turning the focus knob until you can see it clearly. You can use teasing needles to move the specimen around to look at it from different angles. Sometimes you can get a better view of the specimen by looking at it from the top lit view by shining a more intense light on it and by turning the bottom light off. It's something you can try and see how it works. Sometimes it's a better thing, sometimes not. A compound microscope is compound because it has a variety of objective lenses. These are the lenses that are closest to the object that you've placed on the stage that you want to examine. The eyepiece can be one or it can be binocular. There are usually two adjustments, and different microscopes are built in different ways. The part in the back that you would hold the microscope from, or that supports all the apparatus, is called the arm. The adjustment is coarse and fine. Sometimes these knobs are together so that one's embedded in the other one. The fine adjustment moves the lens closer or farther away from the specimen in very, very small increments. And this really is what focuses the image. The coarse adjustment puts it sort of into view, but you don't want to start adjusting this so that the apparatus goes down rapidly, because you may hit the slide and break the glass or scratch or damage the lens. So first, lower your objective lens close to the slide, very, very close, while you're not looking through the eyepiece. This way you can get it very close to the slide and then adjust it by moving back up, or adjust your fine adjustment by going back up, and it may take quite a while to get into focus. So you may have to repeat this and then go back to the coarse adjustment and move it up a little farther before you start with the fine adjustment. The diaphragm below the stage is like the iris in your eye, and it adjusts the amount of light coming into the scope through the hole in the stage, called the aperture. Notice there are several lenses. The most powerful is the longest, and the power of a microscope is determined by multiplying the magnification of the ocular lens, which is held by the eyepiece or the eyepiece tube, and it is usually 10x, but some are 15. I prefer 15, and I buy for myself an eyepiece that is much wider because of my glasses. It's easier to use for me. Or eyepieces in the case of a binocular head, which I prefer, of course. The smallest lens is usually about 4 times magnification. If this is 10 and that's 4, then the total magnification is 10 times 4 equals 40 times. The next lens is objective lens is usually 10x, then 40, then 100. Multiply the two together to get your total magnification. When you are at higher magnifications, your field of view gets much smaller, and the depth of focus is much, much shorter. So this means if your microscope slide is made to be too thick, you may not be able to focus on some items because they're too deep into the medium that the specimen is on under the cover slip. So that can be a problem. Experience is the best teacher, and practice is needed to understand what's happening and to be able to do a good job with it. The base, of course, supports the microscope, and for safe carry, you should hold a microscope with 2 hands. One hand on the arm, one hand under the base, and carry it carefully so that you don't bang it against solid objects, which could damage the lenses and any part of the apparatus that has to do with lenses. Okay, so what we want you to do is go take your worksheet. Go to a lab station in pairs, pick a partner, and work together to fill out your worksheet. Each of you will fill out a separate worksheet. Work together to do it. Fill out the definitions of the vocabulary. Label your microscope photograph in the lab handout. Do this for the compound microscope and also for the dissecting microscope. answer the questions associated with the lab, and then after you've become familiar with the apparatus, we want you to take slides that will be on the lab tables that are prepared slides. They are labeled as to what you should be looking for in those slides. Put them on the microscope. Start with low power. Center the object on the field of view by putting it at the end of the pointer that's embedded within the lenses. Then, when you carefully switch to a higher objective lens, the item will be centered, and all you have to do is carefully and properly focus to find it so that you can examine it. Each time you move to a higher lens, a higher power objective lens, please use the coarse adjustment to raise the apparatus on the arm and then lower it to the slide after you've switched objectives, and then focus upward to find your specimen. Have a good time. Fill out the worksheets. I will probably grade them tomorrow or the next day. If you don't have enough time to finish, perhaps tomorrow there'll be some additional time to finish this lab. Okay, have a good day, and I'll see you when I return.